Good morning. My name is R. Sricharan and my roll number is 5D1. Today, my topic is reverse saturation current in PN junction diode. PN junction diode. Introduction to the PN junction diode. Definition: a PN junction diode is an interface or a boundary between two semiconductor material types, namely the P type and the N type, inside a semiconductor. The P side or the positive side of the semiconductor as axis of holes, and the N side or the negative side as an axis of electrons. In a semiconductor, the PN junction is created by the method of doping. The process of doping is explained in the further details in the next section. Used PN junction diode. You can see the diagram and easily understand. The blue color circles are the empty holes, and plus yellow color box the circles are an depletion region, and red color circles are the free electrons. And left side is P type material and right side is N type material. Let us consider a thin P-type silicon semiconductor sheet. If we add a small amount of pentavalent impurity to this, a part of P-type will be connected to N-type silicon. This sheet will now contain both P-type region and N-type region and a junction between these two regions. The process that flow after the formation of p-n junction are of two types, diffusion and derivative. As we know, there is a difference in the concentration of holes and electrons at the two sides of a junction. The holes from the p side diffuse to the n side and the electrons from the n side diffuses to p side. This gives rise to a diffusion current across the junction. Also, when an electron diffuses from the n side of the to the p side, an ionized donor is left behind on the n side, which is immobile as the process goes on. A layer of positive charge is developed onto the n side of the junction. Similarly, when a hole goes from the p side to the n side, an ionized acceptor is left behind the p side, resulting in the formation of a layer of negative charges in the p side of the junction. The region of the positive charge and negative charge are either side of the junction is termed as the depletion region due to this positive space charge region on either side of the junction. An electric field direction from a positive charge towards the negative charge is developed. Due to this electric field, an electron or the p side of the junction moves to the n side of the junction. This motion is termed as the drift. Here we see that the direction of drift current is opposite to that of the diffusion current. Biasing conditions for the PN junction diode. There are two operating regions in the PN junction diode, P-type and N-type. There are three basing conditions for PN junction diode, and this is based on the voltage applied. Zero bias, there is no external voltage applied to the PN junction diode. Forward bias, the positive terminal of the voltage potential is connected to the P type while the negative terminal is connected to N type, as well as reverse bias. The negative terminal of the voltage potential is connected the P type and the positive is connected to the N type. Forward bias of the PN junction diode. First one, battery induced electric field is going towards N type. Built in electric field in second one. Third one, conventional current goes towards N type and electric current P type. Reverse bias of the PN junction. No current flow. Battery induced electric field. Build it in electric field. Reverse bias of the PN junction. The reverse saturation current caused in PN junction diode is caused by minority carriers. The rupture of covalent bond creates the minority carriers in the material, and it slowly depends on the temperature of the material. When the temperature is maintained at the certain constant value, the generations of minority carriers is constant. The drift current due to the flow of minority carriers is called the reverse saturation current and is independent of the value of applied bias voltage. Thank you giving for this great opportunity to me to explain a topic in front of you.